Welcome back. This is Mr. Hassan's Maths channel, and this is question number 16 from the May-June 2018. This is the Edexcel IGCSE Mathematics A paper. This is 4MA, and this is paper 2 higher 2H. And here we have a question about proportionality or variation, and we're told that R is proportional to T squared. That means R is directly proportional to T squared. Okay, so sometimes it will say proportional to, sometimes it will say directly proportional to, sometimes it will say varies as or varies directly as. All of those are the similar phrases which mean the same thing. Now, if something is proportional to something else, then it's equal to some constant times that thing. So if R is proportional to T squared, that means we can say R is equal to some constant which we'll call K times T squared. And if you want to find a formula for R in terms of T, this is not enough. We have to find the value of K if they give us further information about values of R and T. In this case, they didn't give us explicitly any values of R and T, but they did give us this graph from which we can read off values of R and T. Now, somebody might think that one of the obvious values of R and T would be the origin, 0, 0. But the problem with using the point 0, 0, where both R and T, remember the first coordinate is like the x one, the T, the horizontal, and then R, they're both 0. So when you put T as 0 here, you'll have K times 0, and you won't be able to find what K is. So that's not good enough for us to use to find what K is in this particular case. So we got to think of other values. So we have to look for points which we can read accurate values from. So I wouldn't choose 1 and whatever this value is because it's not precise. But I would choose 2 and this value because it's exactly, on exact value. So when T is 2, we can see R is 10. T is 2, R is 10. So we can use that value of T and R in order to help us find what K is. That's all we really need, but if you look, there's not really any other precise values apart from, we could use this point if we wanted to, which is 4 and 40. Both of those should give us the same value of K. So as long as they're precise values going through exact points, that will give you the correct answer. So now I'll use the point 210. Okay, this, remember, is T, this is R. So I'm going to put 10 equals K times 2 squared. So 10 is equal to 4 times K. 2 squared is 4, so then we can divide both sides by 4. So 10 divided by 4 equals K. So we can say K is equal to 5 over 2. So now we have our formula. R is equal to 5 over 2 times T squared. And that is our answer. We can write it as 2.5 if you want. So this is the formula. R equals 5 over 2 times T squared. Always write the answer in the answer space at the end. And there's the answer. If we had used 4 and 40, we can see it would still work. We'll have R equals K times T squared. 40 equals K times 4 squared. So we have 40 is equal to 16 times K. If you divide both sides by 4, you have 10 equals 4K. In fact, we're going to divide it by 8. We'll have 5 equals 2K. So K equals 5 over 2. Exactly the same value of K. So it doesn't matter as long as you use points which go through exact values so you can read them accurately. So that's part A of question 16. There's also a part B of this question. Okay, so it says given also, so we worked out first that R equals 5 over 2 times K squared. They've also told us that given also that R equals 8 over 5x, show that T is inversely proportional to root x. Inversely proportional. So basically when something is inversely proportional, then T is proportional to 1 over root x. That's what this means. T is proportional to 1 over root x. So we could prove that we have these expressions for R, one in terms of K, one in terms of X, that we can link them together. This is 5 over 2T squared, sorry. One in terms of T and one in terms of X. We have to prove that they are basically linked together in this manner. So we could have to prove that T is going to be some constant divided by root X. Inversely proportional means proportional to 1 over whatever it's proportional to, root x. That means T is equal to a constant divided by root x. That's the difference between inverse and direct proportion. So T is inversely proportional to root x, so T is equal to K over root x. We've got to show that we can write an expression with t and x in it, which gives us something that looks like that. Okay, so what we can do is we can solve these two equations simultaneously. We can get rid of the r. Okay, we can, for example, what we could do is we could say, let's replace this r with 5 over 2 t squared. So we say 5 over 2 t squared is equal to 8 over 5x. And what we can do is we want to express t as a subject. So if we multiply both sides by 2, okay, if we multiply both sides by 2, the 2's cancel, we're left with 5t squared equals 16 over 5x. And then if we divide both sides by 5, divide this side by 5, we're left with t squared is equal to 16 over 25x. Okay, so 16 over 25x. So we can say t, now we're going to take the square root of both sides, so t is equal to the square root of the square root of 16 over 25x, 16 over 25x, which will give us, that's going to be 4 on top, that's going to be the square root of 5, and then you're going to have x underneath. This is the same, the square root of, what am I doing? 4 over, the square root of 25 is 5, and you have root x. Okay, 16 square root is 4, 25 square root is 5, and the square root of x, right at the square root of x. Now 4 over 5 root x is the same as saying 4/5 times 1 over root x. And we know 4/5 is 0.8, so this is like 0.8 times 1 over root x. So we can say t is equal to 0.8 over the square root of x. So we can say that this is in the form t equals k over root x. So therefore t is inversely proportional to x. So we can just write that in words if you want. T is inversely proportional to the square root of x. Okay, so we prove that by writing in this form, and there we have the answer to this question. Okay, and that's the answer. Okay, so that's fine. So that completes this question number 16 from the May-June 2018 Edexcel IGCSE Mathematics A, paper 2H. Other questions from this particular paper you'll find in the playlist that will appear in this region over here. If you don't find a question there that you want answered, just send me a message, and as soon as I get the time, I will try to upload that. And here you will find my playlist for variation from Edexcel questions. You might find it quite empty in the beginning because I'm just started to do Edexcel questions now for IGCSE. Here you'll find a lot more questions from my Cambridge collection of variation, which very same concept basically. So you'll find a lot more examples of this type of question there. And you can subscribe to my channel by clicking on the link up there. Thank you for watching. See you soon.